Okay, welcome back to my second episode of the very basics of fixing things. Today I'm going to focus on your primary tool that you use to diagnose problems, and that is your trusty multimeter. Now, multimeters come in all shapes and sizes. I've got several different ones. But we're going to go over the very basic functions and how they are used to detect faults. If you'll take a look, if you can see that, right there is a symbol for a diode. It's like a triangle with meeting a line. That's diode. It's also coupled with the symbol of a sound. This tests for continuity. It does two things. It tests diodes and it also tests for whether lines are connected. And it will alert you using a sound. And the way that works is your multimeter sends out a signal, a DC signal, and if the circuit is complete, it makes a sound. And you also need a little bit of voltage to check a diode. So that's why they tend to put those two things together. To start you off, I'll use, instead of a board, I'll use a common wire. On this wire, this is pulled off for a video card, the yellow is voltage in and the black is ground or voltage out. In a laptop, there is really no ground. It's actually voltage out. But let's not get confused. So these two yellow should not be touching each other. These two yellow wires should not be touching. Also notice I'm using, if you'll take a look, I'm using very thin leads or probes on my multimeter. These do cost extra. They are better because with thicker probes like this one here on this multimeter, you can't get into as smaller areas, and you will find getting thinner probes will really help you. I'll just put that back. Come on. All right, so I'm going to stick the probes in. It doesn't matter polarity, so I'll stick a red in this end one here where one of the yellow ones is, and I'm going to stick the black one in where the black one is. And it's not beeping. But if I stick yellow to yellow, it's beeping because these two are not supposed to touch each other. And through the multimeter, they're touching each other. Okay, so that's why it's sounding. But this line is good because black and yellow are not grounded to each other. So you check this to make sure that things that aren't supposed to be touching aren't touching, and it shows you the problem where things are touching that should not be touching. And that's the main way people figure things out. You can also use impedance mode or ohms mode, and then when you get really low readings, that means that there is low impedance. There are things touching that should not be touching. Let's go ahead and go to the microscope, and I want to show you an example of how they do this on a board. On a board, everything that is metal is ground, like your screw holes or any device like that. Any metal device is ground. So you can put those anywhere, and that includes over here on the other side. You can put them on any metal device, and that will connect to ground. So the first thing that you do is get to the area that you're wanting to test. Take your black lead, which actually it doesn't matter, but we tend to view this one as ground and then this one as voltage in. But when we actually do diodes, we flip them. And the reason that we flip them is because we're injecting voltage, and that can have an effect on capacitors. So I'm going to be placing my probe on, actually I'm going to place it, don't know what that was, I'm going to place it right here. You can see I've stuck my probe in there. Now I'm going to go over here, and the reason I'm going to go over here is because this is where the voltage in actually starts. And you can see I've done some things over here. There is a missing MOSFET, okay? And there were two capacitors right here, 1 and 2. So I'm going to touch this, and it just made a little beep, so it is not touching ground. This is, and so is this, and that's okay. Because these are what we call bypass capacitors, and we'll talk about them more later. What we don't want touching the ground is the drain of this MOSFET. Here is the gate right here, where at least this is where the MOSFET goes. There's the gate, that's what controls the MOSFET. This is the source. Okay, we don't have a short on the gate or source. Actually, this is the gate right here. It shows you right here. Okay, this is just a pad to secure it down, and then this is the drain. And as you can hear, it is touching ground. Now, I have removed the MOSFET itself and discovered that that was not the problem. When you find a short, the first thing that you find that's shorted is very often not the cause of the short. The cause can be anything that's on that circuit, on that particular circuit area. The only things that can't cause a short are inductors, which I'll show you right here. These little gray blocks, those are actually coils. There's a coil inside, and we'll talk about what they do. And resistors cannot cause a short. And the reason for that is neither one of them are directly connected to ground in any way. So that's why they can't cause a short, even if they go bad. Okay, so now another part of your multimeter that is the most often used is your ohms mode. See the symbol for ohms right there? That's resistance. That's how much impedance there is between your probes. How much impedance there is on a line. And there are some that have automatic settings, and then there are some like mine that you have to get into the range. I really like this one because it's got some features that others don't like. For instance, I can measure capacitance, which you don't find on many multimeters, and I can even measure heat, and I can test some transistors. So I really like this one. Got it for my birthday. Okay, so in ohms mode, let's see what that short looks like. So I'll place black on ground, and I'm going to put my, okay, it's saying 0.2 ohms. That is a dead short to ground. So you can do it either by the beep, or you can measure in ohms. So that's a dead short. And that is one of the main ways people find out where there is something wrong. Now, in a future episode, we're going to figure out there are several different ways for you to find out exactly where that short is originating. On this board, you can see I thought it was coming from the video card, and I removed it. I was partially right, because there was a short on both the ground and the source on that one. When I removed the video card, the short on the source disappeared. So there is still yet a short on grounds on the drain somewhere, and I'll show you how we do that. But first, I'm going to show you impedance mode. So I'm going to move my, here we go, let's go right here. Let's get right on that inductor. So I'm going to put one on ground, and I'm going to put one on the inductor here. And see, with these really thin ones, you can really stab it in there, okay? And it is not reading inductance, and that's because I have my inductance set too low. So I'm going to go up to the K's. Let's see if it gives me a reading on K. Yep, it gave me a reading shortly. So I'm going to stick it up to the tens of K's. Let's see what my, there we go. So the impedance beginning right here to ground, that's what it's always measuring to, is to ground, is about 10K, and that's about right. So our problem on this board is from here back. It is not from here forward. And I'll show you right there, all these little black things on the board, the little black squares, they're resistors. And let's see what this, this is supposed to be 2.2 ohms, so I got to go back down to the smaller ohms. I think it's 2.2. Yes, and it's reading exactly 2.2 ohms. Okay? Now the way that works is it's sending out a DC signal. And when the circuit is complete, it goes through the multimeter, it is then able to measure, because it knows how much voltage it is putting out, and it does the calculating. So this is your primary tool for finding faults. So what I recommend is you go out and you get a multimeter that you really like. But you can start off with a very inexpensive one. My first multimeter was very inexpensive. As long as you have ohms and diode mode and voltage, you'll be fine. You don't have to have the extra stuff.